All right, lesson 5.5 is all about solving a quadratic equation. So there's several different methods for solving a quadratic equation. The whole second half of chapter 5 discusses how to solve them. So the whole first half was all about how do you graph them, how do you move them around on a coordinate board, all of those kinds of things. The second half of the chapter is all about how do you solve them. And so what is the solution of a quadratic equation? When we solve problems, we're looking for the answers. And there are many answers or many names for the answers to a quadratic equation. So you know how we are as mathematicians. We like to give things several different names. So the answer to a quadratic equation, or to solve a quadratic equation, you are looking for the solution. So that's sort of the no-brainer, right? If we're looking for the answer, we're looking for the solution. But those solutions are what we call zeros. Okay? And zeros mean the same thing as x-intercepts. So anytime you hear the word solution, zeros, x-intercepts, they all mean the answer. It is the solution. It's what we're looking for. And the solution, or the zeros, or the x-intercepts are actually ordered pairs. They are actual points or ordered pairs. This one is a solution. It is an x-intercept. It is where the parabola crosses the x-axis, and this one is a solution. And these all have an ordered pair. Whatever it is, those would be considered the solutions to the equation. And so when you write the solutions, you put them in what we call braces, not parentheses. So in this case, I would have two solutions, and I would write them in there as their ordered pairs, xy with a comma, and then the next one, xy, and then I close the brace. Those braces mean that I have a set of answers. Sometimes I have only one ordered pair, and that's when the vertex is what crosses the x. Okay, so let's think about that. One solution would be where the parabola's vertex is the x-intercept. Okay, and that would be one solution. So we would just have this brace with the one point where it crosses. Or we could have two solutions, like I have over here, and we would write it just the way I just showed you. And sometimes we would have a situation where there's no solution. So maybe the parabola is up here and it never ever crosses the x-axis. So there would be zero solutions there. We would say that there is no solution because it does not cross the x-axis. So those are going to be sort of the three situations we will run into. So how do you solve a quadratic equation? There are many methods. Like anything else, just like systems of equations, when we were graphing those linear lines and we were looking for the places where the lines meet, we had several different ways to find those points. We used graphing, which was the least accurate. We used substitution, and we used elimination. So with quadratics, it's very similar. There are several different methods, the first being graphing, and it is the least accurate. Graphing is always the least accurate method for everything. It's a great way to sort of get an idea and a thought behind what it is you're actually solving for when you do it algebraically, to see the picture and learn about it. So that's always where we start. Graph the parabola and identify the solutions. Well, that sounds pretty simple. So let's see if we're able to do that. I'm going to scoot my screen up, and then we're going to talk about how to do these two problems. I'm just going to scoot my screen up a little bit. Oops, too far. So we'll stop right about here. I want to be able to get the graph in as well. Okay. So we are going to start with how do you graph a parabola. Well, we learned that in the first half of the chapter, right? To get h, that is the x-coordinate of our vertex, right? We have to do opposite of b over 2a. So a is 2, b is 4, c is -6. Opposite of b, -4 over 2 times a. It's going to give me -4 over 4, and that gives me -1. Whoops, -1. And so that tells me that my axis of symmetry, my AOS, is x equals -1. So I'm going to plot that, -1. Here's my axis of symmetry, okay? X equals -1. All right? And I know that -1 is the coordinate of my vertex, or the first coordinate, because remember the vertex is HK. And so I ask the question all the time, how do you find K? And most of the time you all can tell me you plug in the -1. So let's plug in -1 to our function. 2 times -1 squared plus 4 times -1 minus 6. And we have to do this calculation. -1 times -1 is +1 times 2 is 2. 4 times -1 is -4, and then minus 6. So I end up with an answer of -8. So my vertex is at -1, -8. So of course -8 is a little bit off my graph. So let's just pretend it's here for now. Bear with me. Okay, we're going to put -8 down here. And we'll call that our vertex. Remember that you can easily find your axis or your y-intercept right from your equation. So here's my y-intercept. I'm just going to go ahead and graph that. And I'm going to mirror it over. So it's 1 away from my line of symmetry, so I'm going to put it 1 away over here. And I'm trying to figure out, remember the solutions, where it's going to cross the x-axis. So I have to keep going. I have to find those points. And so remember we talked early on about the fact that you have a value here for -2, and you have a value here with your vertex at -8, and you have a value here at -6. So you have these three values, 0, -1, and -2 for your x's. You already know their y values. And so you're going to keep going in order. And before I said to you, you always want to try to use the very next one, so either 1 or -3, and plug those in to see what your y values are. It is ultimately very important that you do that in this situation, and the reason being, if you skip 1 and you use 2, you're going to be maybe up here above, maybe above your graph, above your x, and that doesn't help you. You need to know where it crosses the x-axis. You would then have to backtrack and choose 1. Our guess would be that it's probably growing pretty steeply here, and so we're going to keep going right in order so we don't miss where it's going to cross the x-axis. So I'm going to then plug in f of 1, and I'm going to try to find, I want my answer to be 0. That's what I want. I want to find where it crosses. I want to find where x is 0. Okay? So I'm going to plug in the 1. So 2 times 1 squared plus 4 times 1 minus 6. So 1 squared is 1 times 2 is 2 plus 4 minus 6. And 2 plus 4 is 6. And 6 minus 6 is 0. So there is y equals 0. That's what I was looking for. So at 1, I'm at 0. X is 1, y is 0. Perfect. Mirror that over. It's 2 units away from your axis of symmetry, so go 2 in the other direction. And we don't need to do any more work trying to graph it because we found our solutions. This particular graph crosses at -3, 0, and at 1, 0. And this is how you write your answer. That is the solution. Those are the two places, -3 and 1, where it crosses. Now, oftentimes you're going to see your answer written like this, -3 and 1. It's asking you for the 2 points where it crosses, so it's okay to give them like this as well. Okay, this is okay. And you could probably use this solution more so than writing them as ordered pairs. Okay, we write them as ordered pairs usually when we're dealing with the intercept, when we're asking for the intercept. I'm asking you for the solution, so you can just tell me -3, 1. Let's do the second example. A is 16, B is -8, C is 0. We need our placeholder. To get H, opposite of B over 2A. So 8 over 2 times 16. All right? That gives me 8 over 32, or 1/4. A really nasty vertex. We're going to go over 1/4, and we're going to figure out what the y value is. So this is a yucky one. Our intercept, our axis of symmetry, I should say, is x equals 1/4. So I have to figure out about 1/4 of a box and draw my axis of symmetry in there. So kind of yucky. X equals 1/4. And I have to find my y value now. So to get k, I have to do f of 1/4. So dig out those fraction apps. Let's put them to work. 16 times 1/4 squared. Let me fix that for you. 1/4 squared minus 8 times 1/4. Okay, so 1/4 times 1/4 is 1/16, and 16 times 1/16 cancels and gives you 1. And then 4 goes into 4 once, 4 goes into 8 twice. 2 times 1 is 2, so 1 minus 2 is -1. So my vertex is down at -1. So thankfully that's a whole number. All right, remember, I'm trying to find the place where these cross the x-axis. This becomes really difficult. What's my y-intercept? Well, that always comes from C. That means my y-intercept is 0. Crosses right here. That's a half a unit away from my line of symmetry right now. Sorry, a quarter unit away, right? Because this is 1/4, and this is at 0. So it's 1/4 away, and 1/4 away in the other direction would be the half mark. And I know it's really hard to see, but let's just use your imagination. So if I blew it up a little bit for you, okay, this would be 0, and this is 1. Okay, and I'm at 1/4 here for my AOS, and I just said my intercept crossed here. That's 1/4 of a unit away, and I have to go 1/4 in the other direction. That puts me right at the half. I'm right at 1/2. Okay? So my parabola is really thin, and I've already found out where it crosses, so my solution is going to be 0, and it crossed at exactly 1/2. Okay? So that is the strategy of graphing. Let's talk about what happens when we're graphing the solution and the points don't look like they're going to cross where we think they're going to cross. Let's scroll this up. You're going to go to the top of your next page, and I'm just going to scroll my paper up so that we're able to check this out. Let me just scroll this up to the next page. What happens when the solutions are not exact? So let's talk about that. What does happen? Let's do this and find out. We're going to do A is 1, B is -2, C is -4. To get H, I have to do opposite of B over 2A. So the opposite of -2 is +2 over 2 times 1. So 2 over 2 equals 1. So my AOS is x equals 1, and the h coordinate of my vertex is 1. So here's my axis of symmetry, 1. Okay. And I'm going to find k by plugging in f of 1. So 1 squared minus 2 times 1 minus 4. So 1 minus 2 minus 4, or I'm going to end up with -5. So my vertex is at -5. 1, -5. So here we go. There's my vertex. I know my y-intercept is -4, so I'm going to go ahead and put that on there, -4, and I'm going to mirror it over. And now I have to choose what value I'm going to plug in to find where the next value is. So I'm going to choose f of 3. Since I already have 0 is -4, 1 is -5, and 2 is -4, I'm now going to choose 3. So 3 squared minus 2 times 3 minus 4. Okay, 3 times 3 is 9, minus 6 minus 4. So I get a value of negative 1. So when x is 3, y is negative 1. X is 3, y is negative 1. Ooh, so I'm super close, right? I'm really close to crossing the y, but I haven't, or crossing the x-axis, but I haven't quite done it yet. So I'm going to choose the next one, f of 4. So 4 squared minus 2 times 4 minus 4. So 4 times 4 is 16, minus 8 minus 4, and that leaves me with 4. So when x is 4, y is positive 4. So at 4, I'm at positive 4. So this becomes a problem for us because we are trying to find the exact place where the parabola crosses the x-axis. Now, we could, and I will tell you, you could spend hours doing this. We could take some time and try to find the place between negative 1 and negative 2 and between 3 and 4 where our parabola crosses exactly. So we could try 3.5. That might not be it. We might be up here at 3.5. We might try 3.25, maybe get a little closer, maybe 3 1/8. But we would have to keep trying and trying and trying, and it could end up being some really weird fractional answer, and it could take a really long time to find it. It's kind of like that game on Price is Right where you're trying to guess the price and he keeps telling you higher or lower. You could keep going back and forth, back and forth, back and forth, and take a really long time to finally get to that one tiny number that you need. So when this happens, when the one value is below and the very next value is above, we do know that our parabola crossed between those 2 points. And so we're just going to say in our solution, I'll write it up here, we're just going to do this. We're going to say that our solutions are between negative 2 and negative 1, and we're also going to say between 3 and 4. So we've narrowed down where our solutions happen, and that's what we're going to say our answer is when they're not easily found and exact. Okay? So that's graphing in a nutshell. Our next one will be talking about how to solve them by using factoring.